Hey Algebra 2 students, welcome to our first official day of Chapter 3. Chapter 3's topic is called Polynomial Functions. Right, so Chapter 1 we learned about just functions in general, what a function is, right, each input having one output. We learned how to describe them with domain and range. We learned how to move functions around with transformations. We looked at functions that are made up of pieces of functions, like piecewise functions. Chapter 2 was all about quadratic functions, right, a specific type of functions. And now polynomial functions, that's going to be our new focus, right? So what's really nice is Algebra 2 is kind of like a tour of a lot of different functions, and Chapter 1 really just lays the groundwork so we know what a function is and have tools to talk about them. So let's look at what the definition of a polynomial function is. So this is similar to what you'll typically see in a textbook, something of this nature is what a polynomial is defined as. And so all that means is that we've got coefficients, right? Coefficient, and we have x's. X to a certain power, x to a different power. Notice the notation, like if this is x to the 5th, this is x to the 5 take away 1, which is x to the 4th. Right, so it kind of goes down in power. This next one does not have an x. You can think of that as x to no power if you like, or x to the 1st. But that's kind of weird to look at, and it's kind of confusing. So here's a nice example. I really like this example to kind of compare. So we've got some numbers, some coefficients, and then some x's, right? So this is what a classic polynomial function looks like. Notice it is standard, right, in standard form, similar to standard form of a quadratic function. The standard form is highest power to lowest. And you'll notice that the lowest power, quote unquote, is a constant in this case. Like I said, that's kind of like you don't have any x's. If you want to think about it in terms of x's, it's like x to no power instead of x to the 1st power, because x to no power is a 1. But notice what's kind of interesting is you don't always have to go to a certain power, right? In this case, the 7th power is the highest. In this case, 2 is the highest. In this case, 1 is the highest. In this case, you have no x's. So you can really have a swath of different possibilities for what these functions look like. Do also notice that you don't have to go like 7, 6, 5, 4, 3, 2, 1. I went 7, 2, 1. So you don't have to include all the powers in between. You can kind of skip around. So those are examples of what the functions can look like. So we've got exponents, different amounts of exponents, right? So notice it's like powers, like x to the 0, right? That's kind of like this one. You can have x to the 1st, x squared, x cubed, dot, 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 dot. So notice that within that, right, one thing I do want to point out is inside of this group called polynomial functions, so like inside the family of polynomial functions, we have quadratics, we have linear, right? Those are some functions that we've seen before. G of x is an example of a quadratic, h of x is an example of a linear function. Really, the big idea that holds polynomials together is that they, as the name suggests, poly means many, and then nomial typically is like for number, but in this case, it's referring more so to many terms. So a polynomial is a function that's made up of many terms, right? What is a term? If you need a quick reminder, right? It has 1, 2, this one has 4 terms. So a term can be a number, it can be an x, right? It can be a number, a variable, it can be a number and a variable combined. This one here has 3 terms, 2 terms, 1 term. Okay, so these are all examples of what polynomials can look like, and we'll play around with the graphs. The question is, what do non-examples look like? What is not a polynomial? And I'll give you an example of what's not a polynomial. Like I'll make k of x equals maybe So you might be noticing there's something off with this one compared to previous functions that we've looked at, and it's that, right? Notice if I look at the directions, exponent being a whole number, right? A whole positive number, not a negative number. So that's something that is not a polynomial, just for a reference point. What I want you to do is kind of like practice looking at some of these different polynomials. At this box, I've got some examples of polynomials and some vocab words that we typically attach with them, used to describe them. I bet based on your knowledge of prefixes, you'll probably be able to guess which one is which. I'm going to pause the video and unpause when you're ready to check. So most of you will probably be able to match the constant, linear, and cubic functions first. Those are a little bit easier to do. The tricky one is which one is quartic versus quadratic. And a lot of students have trouble because they see the squared and the squared and squared. So the question is, okay, so which one is it? What's kind of tricky about this one here is notice if you do x minus 1 squared, you'll get this. If you do x plus 2 squared, you'll get this. And I'm ignoring the negative sign in front just for now. Think about if you were to multiply all these, not even caring about the negative sign right now, just the fact that you would kind of fill it out like this, right? Also kind of keep in mind the negative, so I won't make that disappear completely. But kind of think about how you would do an area model. Your top would have x squared times x squared as well as the negative. That's like a negative x to the 4th power. So that is why the quartic is this guy, because an x squared times an x squared. And you can kind of put the two squares together for shorthand is a nice way to ease the work there. Okay, so there are our matching answers. And now what we're going to do is we're just going to take a minute and make some observations of what the graphs typically look like. So you're going to see some graphical patterns, and you're going to go to this website here, okay? And you're going to see some graphical patterns emerging, okay? Just in case you aren't able to get the Desmos graph, here are the odd powers. Try and draw a sketch of what the graphs typically look like. Okay, graphs of odd powers with negative signs in front. Go ahead and draw a quick sketch of what the general shape of these graphs look like is. Okay, even powers with no coefficient, like not a negative sign. Go ahead and draw a sketch of what you're noticing. And last but not least, even powers with a negative sign in front. So I'm going to switch over, and these are kind of the general shapes that I was seeing. For the one that we were just on, I'm seeing it goes down, and then kind of here it does some different things. So this squiggle shows the fact that it might be more like this, or it might be more like a kind of U-ish, like a flat line rather than a parabola. Same kind of thing for here. We've got the up, stuff goes on in the middle, and up. The same kind of thing applies for the cube ideas. Cube, 5th power, it goes up on this end, goes down on this end. In the middle, there's kind of different stuff going on. It's kind of a messy sketch. I'm going to try and make it prettier. And that's to indicate that some of them were more like this. Some of them were more like that, right? If we go back to the graph, some of them are very tight to the axis. If we take a look at those. So here were those. Notice as you go higher and higher, right? Red to green to black to purple, it gets closer and closer to that axis. Okay, same kind of idea here. So that's the general shape of these graphs. Feel free to write down anything you're wondering as well. Take a moment to ask yourself or ask any questions you might be thinking. Either they might be answered later in the notes, or maybe we'll talk about them tomorrow. Sorry about this getting cut off. This leads us to something called the leading term test, right? So if I kind of color code, n is even, a is positive, that means an even power with a positive coefficient. N is even, a is negative, even power, negative coefficient. This is going to be odd power, positive coefficient, just to kind of color code them so you can see. And then last one. Okay, so what I'm going to do here is I'm going to redraw my general shapes that we were seeing real quick. Right, general shapes. Okay, and so these are general shapes or end behavior. One trick that a lot of times is important is to be able to write them in words. So with this one, the purple one, I'll kind of split them up into 4. The way you say this in words is as x gets bigger, right? I'll write it in words. As x gets bigger, so does y, which is in words as x approaches infinity, y also gets bigger. Right, so this is kind of saying the same thing here as here. And notice that's because as I go bigger and bigger x's, my outputs or my y values get bigger. The opposite happen, or the same thing happens as x gets smaller, excuse me. As x goes to negative infinity, y gets bigger, right? So that's kind of this side. As x gets smaller, I'm plugging in more negative numbers. Notice my heights or my y values are getting bigger. Okay, so I'm going to write that out for the next couple. Try and write out the statements for yourself and see if you understand like the thought process here. We can definitely talk about this tomorrow because this is a little tricky to get used to at first. So go ahead and pause, try and write out the statements for the next 3. And here are your answers. For the pink graph, right, facing down, as x gets bigger, as I go to the right, my y values go down. Same thing happens as I go to the left, my y values still go down. Notice for the bottom left, the orange one, as x gets bigger, right, go to the right, y values go up. As x gets smaller, y values go down. And then final one here as well. In the second video, what you guys are going to move to is graphing pictures of these functions just to practice what they look like. And you'll see we'll use Desmos as a tool to double check anytime we get stuck. I'll see you guys in video 2.